All right, let's take a look at this. This is sometimes there's three different ones here, right? This is period is 1 over frequency. So a period is seconds per cycle, and the frequency is cycles per second. Right? The units of frequency is seconds to the -1, or hertz is what we can say, right? The unit of period is just seconds. T is just in seconds. Traveling waves. Well, I just can't tell you how much I don't like this formula. Well, why are they using C? It should be V is F lambda. This is true for a light wave, right? The speed of light is the velocity of the wave, and we can go frequency times wavelength. But in general, it's V is F lambda. Hopefully, I don't know. Hopefully, you won't be confused by that when you look it up. But yeah, this is, well, we did a lot of that, didn't we? Okay, and then this is interesting, right? Wave characteristics that the intensity, the watts, intensity is watts per square meter, right, is proportional to, that's what the little lambda thing means. And this is amplitude. And it's squared, right? So if you've got, let's say you got two sine waves, right? And you've got one with a low amplitude, right? And then you've got another one with, say, twice the amplitude. If this guy has twice the amplitude, it's actually 4 times, 2 times A causes 4 times the intensity. Yeah, so then they actually give you questions like that, so that's interesting, right? This is intensity drops off with distance squared, right? And in general, the intensity drops off like 4 pi r squared, and that's because the watts per square meter, whatever that power is, right, is spreading out over the square meter. So if you have a source of sound right there and you're standing some distance away, it's as if there's a big sphere, right? If you're standing here, if you're standing right there, all of that energy, all of that power is spread out over the area of this sphere, right? And the area of the sphere is 4 pi r squared. Okay, so whatever that power is it's inversely proportional to the r squared, and that's what they're saying there, right? And then along with all these sort of vague things, right, they've got this is for polarization. Okay, if you've got polarized light, let's say we've got light that's like this, right? That's polarized this way, and then we have a filter that's at some angle, right? If whatever that incoming intensity, okay, you just take the angle of polarization, the angle between that, right, and stick it in there. So this is polarizing, right? Which means that if they're at 90 degrees, well, cos of 90 is 0. 0 squared is like, that's really 0, Anyway, no light can get through if the filter is at 90 degrees to the plane of polarization. Yeah.